Hello. So in the last video, we learned how to calculate the correlation coefficient. So this video, I'm going to start with another set of data. So this data is about macroeconomic variables in the United States from 1962 through 2015, right? Quarterly data on real GDP growth, industrial production growth, consumer price index inflation rate, unemployment rate, and 10-year treasury bill rate, right? So these are some of very important, most important macroeconomic variables, and usually, they are considered at the same time to understand the status of the economy. Then the problem is we have 5 variables, 1, 2, 3, 4, 5. How can you calculate the correlation between them, among them? The answer is there is no way to calculate the correlation of the 5 variables at the same time. So we have 5 variables. Then what we need to do here is to calculate the covariance or the correlation coefficient, we need to do pairwise. So choose a pair of variables, calculate their correlation, and choose another pair, calculate that, like that. So you have to analyze pair by pair. That's at this level, that is the best way. That's all we can do. Okay. So then you may think it's pretty annoying work to calculate all the pairs, but of course, Excel has a formula to do it at once. So in the end, what we want here is we would like to have 5 by 5 matrix, and we are going to use pair like each. So for example, so choose one variable from the first column and one variable from the first row. Then where they meet is their covariance. Right? For example, this one, 0.18, corresponds to the covariance between treasury rate and GDP growth rate, right? So of course, this covariance must be the same as this pair. This is also GDP and treasury bill rate, so it's empty here because they are the same thing. We only calculate the pair in the lower triangle. Okay, let me show you how to do that. So we have 5 variables. The first is just time. What you are going to do here is choose data tab. Data here. And then choose data analysis option here. You will see a lot of things, and among them, I'm going to choose covariance. Double click. And input range is these 5 variables, and label in the first row grouped by column. Each column is one variable, right? And I will choose OK. And you get the 5 by 5 matrix of covariances. Exactly the same numbers I gave you here. Okay. So GDP. So as I said, this one is the covariance between 10-year treasury bill rate and real GDP growth rate. Or for example, if you take this one, let me choose another color. This one is covariance between CPI, inflation rate, and unemployment rate. So any pair, you can find covariance for any pair from this matrix. And what is interesting here is, for example, if you take this guy is covariance between industrial production growth and industrial production growth. So covariance between the same variables is the variance. So the variance of industrial production growth rate is 21. So covariance matrix not only gives you the covariance, but also gives you the variances, right? So let me reiterate. So diagonal terms, diagonal numbers are variances. GDP between GDP and GDP is its variance. IP, variance of IP, inflation, unemployment rate, treasury bill rate. So it's variances, right? And off diagonal terms are covariances of the corresponding pairs of inflation and industrial production is minus 2.42, right? And GDP and industrial production 7.66. GDP and inflation minus 1.99. So in that way, you can have any covariance from the matrix. So again, when you have more than two variables, you have to work on covariance pair by pair. And this will simplify. This matrix will summarize all the covariances into one table. That is what we are doing. Now then, how can you interpret that? First, remember, covariance does not have the absolute value of the covariance does not have any meaning. So what you can read from the table is only the signs. So for example, here is a plus sign, plus, 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 minus, 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 minus. So that's all you can say. Like for example, GDP, let's think about GDP. GDP has positive relationship with industrial production rate and treasury bill rate. Okay. And minus relationship with inflation rate and unemployment rate. Okay? So that is what we see. Okay, among them, what is like usually we expect when GDP growth rate is high, it is natural to have high industrial production and high treasury bill interest rate, but low unemployment rate. They are okay. But the problem is, why do we have negative relationship with inflation rate? Usually, what you learn from macroeconomics is when economy is doing well, inflation goes up together. But here, something else. The data tells you the other way. So this is a very important puzzle in macroeconomics in the 80s, in 70s and 80s. So I'm not sure how much you learned about it, but in macroeconomics, because of this puzzle, like macroeconomists developed rational expectation theory and more augmented Phillips curve, things like that. So new macroeconomic theory is developed motivated by this weird relationship. Okay, and again, so magnitude doesn't mean anything. So for example, when you compare the covariance between GDP and industrial production, 7.66 versus GDP and treasury bill rate, 0.18, it seems like this is much, much larger, right? However, means nothing. It doesn't imply industrial production rate has stronger relationship with the GDP. So the absolute value means nothing. That is another important thing you need to understand here. So then, let me ask you a question then. Okay, we would like to study the strength. Then, can you calculate the correlation coefficient from this table? Think about that. Inflation rate and unemployment rate. So they meet here. So this is obvious. So this is the covariance. And then what you need is to calculate the correlation coefficient. What you need is their standard deviations. So their covariance is 0.48, and standard deviations can be found from their variances. So 8.26 is the variance of inflation. So if you take its square root, that is the standard deviation. So this is standard deviation of inflation. Similarly, 2.57 is the variance of unemployment rate. So its square root is the standard deviation of unemployment rate. So the answer is D. So I wanted to show you can directly convert the covariance matrix into correlation coefficient. So when you compare the absolute value of the covariance, you have to also think about the scale of the variance as standard deviation. That information is given in here. Okay? Okay, so this is exactly what I just explained, following the formula. But of course, you may calculate the correlation matrix in one step. Excuse me. So, from the data, I choose data analysis. We used covariance formula here, but I'm going to choose correlation and do the same thing. Right? Choose the data label, and you get a similar matrix, but in here the diagonal terms are 1 because this is correlation coefficient matrix. So all these numbers are correlation coefficient. Okay, let me go back to slide. So this is what we get, right? Diagonal terms are all 1 because the correlation coefficient between GDP and GDP itself is 1 because they are the same thing. Their correlation must be perfect. So all the diagonal terms are perfect correlation. And off-diagonal terms are between plus minus 1. All the numbers are in between plus minus 1. And another thing here is those signs minus 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 are the same signs as covariance, minus 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 minus, right? So sign does not change from the covariance, but the magnitudes are the absolute values are standardized to belong between plus minus 1, right? Okay, now you may compare the strength. Of course, the signs are the same, so you may interpret from their signs, but also you may interpret their absolute values. For example, now you can compare the strength of the relationship between GDP and industrial production versus the relationship between GDP and treasury bill rate. So treasury bill rate strength is only 0.02. So actually, GDP and treasury bill rate was positively correlated, but is not strong at all. Nearly uncorrelated. It's very close to 0. But GDP and industrial production is 0.49. So it's pretty strongly correlated. Okay. So then you may compare which relationship is more strong. Okay. Then let me ask you this question. So which pair has the strongest negative correlation? You can simple. If you can interpret the table, it would be easy. So first, negative correlations are here. These 5 negative correlation, 5 pairs. Among them, minus 0.36 is the strongest, closest to minus 1, right? So absolute value is the largest. So that is industrial production and unemployment rate. So the answer is C. So when industrial production increases, unemployment rate will definitely decrease. But still the strength is 3.6. Okay, that's how we use correlation coefficient and covariance when you have more than 2 variables. Idea is the same, just you have to be more careful interpreting and comparing those relationships. Okay, so in the next video, I will start another example, which will be more interesting to you. It's about finance. Okay, so see you later.